All right, so now we're on to example 5 of rationalizing denominators and simplifying if possible. We're looking at the expression square root of 3 over 5 plus x, where we're specifying that x is greater than minus 5. Why is that? Well, if I were to plug in x is equal to 5 or equal to minus 5, I get a 0 denominator, so we get division by 0, and that's a bad thing. So similarly, if I had x less than minus 5, such as like minus 6, if I plug that in, I have a negative denominator, and the entire thing, the entire expression would be negative inside a even root. So we can't have that either, because that would give us something imaginary. So we're going to have to keep this specification here, and it won't really affect too much by the way of process on how we go about simplifying this guy. Okay, so how do we go about simplifying it? We have the original expression, square root of 3 over 5 plus x, and we're going to use the same trick that we've done in the past, just being mindful of using the entire denominator when we do this. So first thing I want to do is separate this off into a radical on top and a radical in the denominator, because at this point I don't have a radical in the denominator just yet, so I need to put one there so I can rationalize it. Okay, so with this I have a radical in the denominator. I'm going to multiply top and bottom by the same thing, namely this, so that I get some cancellation later. So I have root 5 plus x and top and bottom here, just multiplying by 1 in a clever way. All right, so now when I do this, multiplying straight across the top, I notice that I have a square root of 3 times a square root of 5 plus x. So these things can be put under the same radical using the product rule for radical expressions. But we gotta be very careful about how we go about doing that. So I'm gonna put this all under the same radical, and this is 3 times 5 plus x. Make sure you put that in parentheses, because otherwise it's going to look like you're just multiplying 3 times 5 or something else that's weird. So when you combine things under the same radical, you're multiplying the stuff on the insides of the radical. That's why I have the parentheses here. Okay? We're going to use the same train of thought here for these bottom radicals. We're multiplying straight across the bottom. I have the same power on this radical, the square root, so these two things get multiplied together. So this gives me square root of 5 plus x squared, because I'm multiplying this guy and this guy together inside the radical. So now notice I have a square root of a square in the denominator, and I also specified that x is going to be greater than minus 5. So I don't have to worry about 5 plus x being less than 0, or it being 0 at all. So I can cancel this out and not have to worry about putting absolute value bars on this. So I'm going to have the same expression here, 3 times 5 plus x over, well, I'm going to cancel the power and the radical, so this gives me 5 plus x. Okay, so your temptation at this point might be to cancel these guys off, but as I've mentioned in the previous video, when you have stuff in the inside of a radical, it's in a sense locked in there. It cannot be removed, it cannot be canceled. There's nothing that on the outside of the radical that can affect the inside of the radical. Okay? So now how do I simplify this further from here? I'm going to have, well, I could FOIL this 3 through, so yeah, might as well do that. This is an optional step. So 3 times 5 is 15, plus 3 times x, so that's 3x. And I did nothing with the denominator, so that gives me 5 plus x in the denominator. So this was just an optional step. You could have stopped here and that would have been perfectly fine. But either one of these is completely done. Nothing more we can do, can't factor anymore, can't simplify anything under the radical anymore. We are stuck. So with that, we are done.